Hello, let me start my week 7 presentation. This week topic is amorphous rigid parts, a material property study in Isaac. I will go in this order. Mm, Summary, detailed status, and future plans. To represent the material properties of amorphous materials, I applied deformable body material. Pouches and cables have a flexibility and amorphous nature that rigid materials do not have. Like in the video, they move differently from stiff objects. Right now, I am adjusting parameters such as the deformable body material. There are two key parameters. First, Young's modulus. It is the tensile stiffness of the material, that is, how stiff it is. The unit is force divide area Pascal. Second, Poisson's ratio. It is how much volume is kept when the material is pressed and how much is spread to the side. The range is 0 to 0.5. And to compare the rigid and amorphous nature of the prototype, I did a material drop test. In simulation, the core object the core of object, like cable and pouches, is their amorphous nature. So I decided to look at the amorphous nature first before the shape. I compared two Isaacson assets. One is teddy bear. Teddy bear USD is amorphous, and small KLT USD is rigid. To see the amorphous nature, I did a test where I dropped the two materials. Next, I compared the property, that is, the physics. Teddy bear USD is on the left. For an amorphous object, the physics is deformable body material. Small KT USD is on the right. For a rigid object, the physics is rigid body material. That is, a rigid body. And I look at what deformable body material is. After installing iJang I checked the schema USDA file locally. From page 5923 of this file, there is a description of the physics deformable body material API class. I understood the value using the schema USDA file and teddy bear USD. Below are the values of teddy bear USD. I look at the parameters that are different from the default. Density. If you set it to 0, the 0, not 0, auto compute. The simulator computes the density by itself. The unit is mass divided volume. Dynamic friction is 40 is the dynamic friction coefficient. The schema default is 0.25, but the teddy bear is 40, much bigger. Young modulus is 5000. It is the tensile stiffness of the material. The schema default is very big. But the teddy bear is 5000. Poisson's ratio is 0.4. It is how much volume is kept when pressed. It is close to the default, which is almost incompressible, like rubber. Elasticity PPT damping is 0.005. It is a material damping parameter and is the same as the schema default. Damping scale is 1. It is the same as the schema default. I also look at a real use case on the iJasim developer forum. I confirm that deformable body material can make things similar to pouches and cables, but the detailed method and setup were not sure. On the left is the real part I referenced, and on the right is the prototype I made inside ISA. First, I need an accurate reference for this part. Right now, I am using images based on simple guess as the reference. I need detailed values such as size and weight, mass, mass, mass. Second, I need to adjust the numeric value of the deformable body material. For amorphous materials, jittering happens depending on the moving angle and position. I also need to adjust values such as mass depending on the material of the cable or pouch. I still need more discussion, and I'm investigating the material. Now is warm up. This week I studied the material properties of amorphous and rigid parts in IJA. In the summary, I looked at deformable body material and the two key parameters. In the detail, I compared teddy bear and small KLT, and I understood the values with schema USDA. And I made a prototype for the future. I need accurate reference and value tuning. That's it all. Thanks.